So today we're going to be talking about bridging the energy efficiency gap on campus in investment appraisal and organisational change. So I'm just going to present 2 slides by way of introduction and also by providing a little bit of context. But really, most of the work has been done by Ulrich Nissen over there, who is a visitor to the university, and also Mark Mason and Hans Petrich, who are in property services. Let's get started. One of the things I've done a bit of work in the past on something called the energy efficiency gap. And the energy efficiency gap really says that individuals, institutions, economic actors or social actors don't implement optimal or profitable energy efficiency measures. Yeah? So profitable in terms of economics, and in finance would say energy efficiency measures that have a positive net present value. Okay, and it's a really fascinating literature that it has been quite impassioned, because on the one hand you've had classical economists really very upset about it, because it goes against their idea of agent rationality. Economic agents are optimizing creatures, and on the other hand, you have more behavioral saying, okay, we have all these factors that stop optimal decisions. And so we're going to talk about it in the context of the University of Otago. One of the things I really want to make clear up front is, we all leave money on the table. Maybe Mark and Hans are probably the only people in the group, maybe Uli, that probably are optimizing at home. So the reality is all the studies that have been done have tended to find a large energy efficiency gap. Some corporates are quite good at bridging the gap. And so this has led to the expansion of the literature to talk about barriers to energy efficiency. And there's a whole load of barriers. Uli will go into more detail of those, but in this work we're focusing principally on investment appraisal and organisational decision making. And there are 2 that really, well, they're not explicit barriers, or they haven't been given perhaps sufficient attention in past research. There's also very little on the energy efficiency gap in universities. We did find some work, but there isn't that much. And universities, I probably don't need to tell you, are pretty unique organisations. So I'd like to do, as the idea is to write this up into a paper, I'd like to do more reading on this. But there's some theory that sort of organisational theory that describes universities as organised anarchy. So I think some of us might empathise with that. They have multiple goals. They're very strange beasts. They're very decentralised, and they tend to have satisfying decision making. In other words, once they find a solution, they'll take that solution on board, even if it may not be the optimal solution. At the University of Otago, we have an electricity bill that runs around the region of the $9 million mark. So it's quite a lot of money. And we all know universities are under pressure in terms of costs and doing more from less, and we're no exception here with the SSR. Also, it's a cold, wet morning or afternoon, and a lot of people would like to have greater comfort in their offices and so on. In this project, actually, we value Uli and Mark value a couple of energy efficiency projects. One of them was around student flats, and we used that example in teaching to a class in energy finance that we gave, and the students loved it, because they came in at 9 AM and they were freezing cold, from overnight. So a lot of this may be framed around environmental change and climate goals, but there are these other considerations. We need to save money. We need to do more from less. We also need to improve comfort. But of course, there is the motivation, and it is changing in New Zealand. We're moving towards a zero carbon act, and so there's a greater emphasis. So it's just a matter of time before the university, there's greater pressure on the university to cut its carbon emissions. The university has led the way and has targets, but we need to achieve these targets somehow. And if you look at the International Energy Agency scenarios, a lot of their climate modeling see energy efficiency leading to about 50-50, anywhere between 40 and 50% emissions reductions. So, energy efficiency is going to be a big factor in the future. So that's a sort of context. So saving money, I'm from a finance and accounting department, so clearly that's going to motivate me. Improved comfort, and of course environmental motivation for looking at this. And as I said, universities are unique and there's not that much being done. The other thing that makes us unique is it's part of what we call OERC Living Lab. And so this is where we've been working with Hans, with Mark and Hans, on various projects to see how, if academics work with property services, can we have related improvements in how energy is managed in the university? Can we have research outputs from that? And can we improve teaching? Yeah, and as I already mentioned, the data that we found in this case study, in these 3 examples that we looked at, we're starting to use in teaching already. Yeah. The students were definitely very engaged. And so, OERC Living Lab involves Mark and Hans, as I mentioned, property services. A year ago, there was a Frederick DeHaan student from finance and energy studies, did a precursory work around this. But we've had Uli visiting us, and that's helped us to take it to another level. And so Uli comes from Niederrhein University in Germany, and he's been here with us for 6 months, principally in the Department of Accounting and Finance, but working also with OERC a great deal. So we've been really privileged to have him. He's an unusual beast because if you're going to tackle these questions, you really need to understand energy from an engineering perspective, and you also need to understand finance. There's not many of those people walking around, and Uli is one of those, and he's been working at the European level to establish standards for investment appraisal. He'll talk more about that. So it's been really great to have him here. And recently, because the university is going through its SSR, a project management office has been set up. So we've been talking to Andy Jenkins, who heads up the project management office, and the way the university is going to appraise projects going forward is going to be different in general, not just energy efficiency ones, but in general. And there's going to be a set standard or templates and processes that all projects will be assessed against. So it's actually been really exciting to get Andy, been talking to Andy. He's really enthused by what we've been doing, or what these guys have been doing principally. I've really just been a sponsor. And so, what is it we're looking to explore? So how can the energy efficiency gap be continuously bridged in the context of university? And that word continuously is really important. Really talk more about that. The idea that there is a static gap to be filled is not true. Technology is changing all the time. Prices are changing all the time. So the gap, what is feasible, is changing all the time. And how we're going to do that is 3 case studies through the University of Otago, but in the context of international standards in various perspectives. So I guess our contribution here is a precise, one of the things that Uli is going to do is a precise definition of the energy efficiency gap. He's also going to explain why the energy efficiency gap isn't really static. And the other thing that's unique about this, and having done research related, is quite often academics in their ivory towers looking at hypothetical energy savings. Yeah? And so these are ideas that are coming from the actual energy managers. So those are real energy savings ideas. And with that, you have an understanding that things are a lot more complex. Yeah? And so one of the things that we're looking to do is move away from the barriers to energy efficiency and move more towards a roadmap, a solutions-oriented approach to bridging and continuously bridging this gap, with a focus on investment appraisal, energy management standards, international energy management standards, and so related to the conversations we've had with Andy, project and asset management best practice. So with that, over to you.
Thank you very much, Alan. Hello, everybody, also from my side. I will start talking about the energy efficiency gap. The energy efficiency gap of Otago University, if there is one. If so, how big is it, and what can we do in order to bridge it? Before I focus on what we've done, related to the University of Otago. Let me just briefly go through, if not explain what energy efficiency gap means. What we want is it is the difference between actual energy efficiency, and the optimal energy efficiency of a facility, of an appliance. And we want to, as I showed here, we want to bridge it in a way that it's an economically beneficial exploitation of the energy efficiency potential. And we try to apply this on the University of Otago. Before I go into details, let me just quickly show you the results of our first quick investigation. That is this year. So we selected 3 areas, projects, if you like, we collected all this relevant energy engineering data. We prepared it for a valuation. We did the valuation. The results are here. Quite interesting, I think. I will go into details a little later, just to give you a very quick overview at the beginning. So what we found out is that with these 3 projects, extending district heating systems, I explained it a little bit later, then I mentioned this already, so the energy efficiency measures for the student flats, and another 3rd project, conservation of adjacent building in regards to campus development. All the 3 projects together would already generate a return of almost $12 million. Calculate net present value. I'll show you later how we got it. And this is only for 3 projects. There are quite a few more. So this is a minimum, if you kind of try to measure the energy efficiency gap. This is an energy efficiency gap, value. So I come to this again later. So first of all, as I said, let me just try to explain what energy efficiency gap is for us. As I said, we want to bridge it, but the bridge is not easy. Bridging the gap is not easy. Why? Because there are a lot of barriers. This is what several scientists, researchers have already found out. You can find a lot of literature about it, either theoretically or empirical studies. These investigations have shown that there are lots of barriers. They are categorized often like this here: access to capital, for example. That means when you have an idea to reduce the energy consumption, to improve the energy efficiency, in 99% of all cases, it is you have to invest something. It's an investment first, and that means you need capital. Sometimes you have problems in accessing the capital that is needed. Then split incentives is another category of barriers. That means it has to do with have the right people that do the investigation, that have the motivation, and these kind of things. Bounded rationality. This is about knowledge. Have the right people there. They should be motivated. They have to have the right knowledge in order to find out what the energy efficiency potentials are and to be able to value them. Then hidden costs. This is for, it takes a little while. Sometimes it's difficult to find out what is possible. You have a big process, a very energy intensive process, a machine or a big heating system or whatever. And in order to find out what the energy efficiency potential is, you have to go through it. You have to analyze it. You have to find out what is the actual, what is the baseline consumption, and what can be done in order to reduce it. What would be the result of, some sort of measure. And this is effort. In other words, hidden costs. Payback time restrictions is another area of them. Very often, many companies, you have as the first priority for investment decisions, the payback time is very often number 1. And this very often kills energy investment ideas, energy efficiency projects, because usually energy efficiency projects are long runners. They need time. They have very good net present values or internal rates of return, but it takes 5, 6, 7 years or so to get the money back. So the payback is not perfect. But if the company has the payback time as the first priority decision instrument, then you've got to have a problem. Imperfect information and procedures. Either there are procedures that kind of block activities in order to find energy efficiency measures. So there are lots of barriers that should be removed in order to do something, in order to make it happen. The barriers to energy efficiency together, they are defined as a postulated mechanism that inhibits a decision or behavior which appears to be both energy efficient and economically efficient. So what is necessary is we need to do something. We need to have some sort of a concept. That was the idea. Development of a concept for the Otago University to bridge the gap based on literature study and experience from project cases. Okay, let's go one step further. So we try to bridge the gap. So we focus on the gap. What is the gap? The gap, as I said already, it is the actual energy efficiency compared with the optimal energy efficiency. So the focus is on energy efficiency. What is that? Energy efficiency is usually defined as useful output divided by energy input. So it's not just the energy consumption. From the energy point of view, from the energy efficiency point of view, it is acceptable to increase energy consumption as in cases in which the useful output increases also. Yeah? So this is relevant here. So we are not talking about energy consumption solely. We are talking about energy consumption in relation to the driver. So what is energy efficiency in practice? Here's an example. Boiling water, for example. You want to boil 10 liters of water, and you need around about 1 kilowatt hour for this. And you write such a quotient: 10 liter boiling water divided by 1 kilowatt energy. This is the value of the energy efficiency. Often people have problems using this energy efficiency value. Sometimes it's a little bit difficult to understand. And therefore, in most cases, you see the reverse, the inverse formula. So you just put it upside down, and then you get not the energy efficiency, you get the energy intensity, which is energy input divided by useful output. For example, in our example here, the energy efficiency of that, so 10 liters boiling water divided by 1 kilowatt hour is not so easy, it's not so handy to use. But if you turn it around, you get 0.1 kilowatt hour per liter boiling water. It's easier to understand. And it's easier to convert to currency, for example. Yeah, this could, this is, just check how much does 1 kilowatt hour energy cost. This might be gas, 10 cents, for example, and then you get 1 cent per liter. So it's very easy to understand. And in practical industry projects, we are very much used to use energy intensity instead of energy efficiency. Although we say we want to increase the energy efficiency, but we calculate energy intensities. We will do this later. You will see. Okay. Next point. So we talked about, I explained energy efficiency, the formula. And now we should talk about the energy efficiency gap. What is that? The gap is commonly defined as the difference between actual, I said this already, and optimal energy efficiency. So the question now is, what is optimal? Here, what is optimal? So, answer, there is not one optimal efficiency. There are different kinds of optimal efficiency. So that we have to differentiate. And we have to select one that should be the benchmark for our actual energy efficiency. What do I mean? Usually we differentiate three types of energy efficiency. The thermodynamic optimum, the technological optimum, and the economical optimum. All three of them could be the benchmark for comparing with the current level of efficiency. What do these different optimums mean? What are the differences? The difference between the thermodynamic optimum and the technological optimum is the technological innovation. This here is the absolute limit. This is what theoretically could be possible in the future. Yeah? More efficiency is not possible as far as we know at the moment. That does not mean that this is practically possible. This is theory. And the difference between what is theoretically possible and what could be possible in real life, this is then the technological optimum. This is the technological optimum. So this is a matter of technological innovation, technological development to go from here to there. The difference of these two bars here could be named technological gap. This is one part of these kind of different gaps that we should discuss. So this is the difference between thermodynamic optimum and technological optimum. What is the difference between technological optimum and economical optimum? What is this? Let me show you one example. A practical example. This is a house, and this might be your house, and you're thinking about, increasing also improving it by insulation, for putting insulation layers to the walls. Here are the different, in this illustration, you can see the relevant costs. So this line here, this function, is the energy cost function depending on the insulation thickness. So this is what you can, vary the thickness. You can say, okay, I take 5 centimeters, 6 centimeters, 10 centimeters, 12, 14, 20 centimeters, whatever. So the costs, or if you like, the energy consumption as the reaction on the insulation activity would go that way. So the first centimeter has a great impact, but the impact goes down from 1 centimeter to the other. Yeah, it goes that way. So in other words, this is the output of the activity. This is the result. So the thicker, of course, the smaller the cost, but the marginal costs, the marginal savings decrease. Right? So on the other hand, you have the insulation costs. This is the material and the putting the layers to the wall. It is a kind of like a straight line here, like this. And if you put these cost lines together, you get the total costs, and then you can find the optimum. So this is the cost of insulation costs. This is investment at the very beginning, and here this line should be the discounted cost reduction over time. Discounted over time. So you say 20 years, so and so many kilowatt hours that I would save times the discount rate, and then you get this line. You put them together. This is the net present value, the minimum net the minimum negative net present value of the whole thing. And so this is the optimum, the lowest costs. All right. So I wanted to, with this illustration, I wanted to show the difference between the technological optimum and the economical optimum. What do I mean? What I can do now is I could, I follow this, cost function, and I, after, I don't know, a very, big thickness here, I might touch the asymptote, and I could call this is the technological optimum. Better is not possible. It is, the limitation here. So this is the limit technologically, but apparently not economically. This is really expensive. Yeah? but it's possible. On the other hand, we had here the economical optimum. This is the economical optimum. It's not that thick. So this might be, I don't know, 1 meter thick, yeah, of the thickness of the layer. And this is probably, I don't know, 12 centimeters or something. So, so this is, first of all, this is the difference, economical optimum and technological optimum, okay? Our question now is, what are the parameters? The parameters can be found out by, varying, the influence factors, the drivers of these functions. For example, what can I do? I can say, look here, this was my installation cost. What happens if the material, the price of the material, decreases? Then the function goes from here to there, this red line, right? So this is a little bit cheaper. And on the other hand, if the energy prices rise, for example, then this cost function here goes up. And if this goes up from gray to red, and this goes down from gray to red, then we have a shift from this optimum to that optimum. So that means the parameters of the economical optimum are, first of all, the investment prices of what you have in mind when you want to increase the energy efficiency. Yeah, here, this is the investment. And if this investment prices go down because of mass production, whatever, this is good for energy efficiency because the optimum goes from here to there. Or it is good for energy efficiency when the energy prices here, from gray to red, go up. When the kilowatt hour becomes more expensive, then we have such a situation. All right. So in other words, the technological optimum and the difference between technological optimum and economical optimum could be named a cost gap. It's depending on energy prices and investment costs. So we're not talking about this. This is determined by technological development and by external cost settings. We're talking about this, the energy efficiency gap. This is the remaining part of the difference between the current level of efficiency and something optimal. So it is the difference between current level of efficiency and economic optimum. This is what we think we should exploit, which generates a positive net present value. But many companies, most of the companies, they have this gap, but they don't do it. So it is the energy performance improvement potential that could be exploited economically beneficial. So, and as I said before, the prices of investment costs and also of energy play a major role here. These gaps here, how big they are, this is dynamic. It is not, Ivan said this already, it is not static, it's dynamic. So that means, when we want to get rid of, or when we want to, exploit the potential that might be there, we should try it on a regular basis, not just one time. It's not a static thing, it's a dynamic thing. Okay, let's try to summarize what I've said so far. So first of all, there's an energy efficiency gap. Most likely also, we know it already so far, at the University of Otago. Like in all organizations, there is a gap that we should bridge. There are lots of barriers that should be removed in order to exploit it. We should need a platform, an environment, something that helps us to continuously exploit the economically beneficial energy efficiency potential in a way that this something must help us to remove. It should be dynamic, therefore continuous, and it should be, as I said, it should, tell us the economically beneficial energy potential. So it should tell us what the positive net present values are, and this something should remove all of the barriers, and build the bridge. This is what we want. So having this in mind, we started to generate ideas. What can we do in order to bridge the gap here at the Otago University? And one first element that came in our minds was ISO 15006, an international standard that was released 2014. And the idea was that we could use this standard, which has already, and I'll show you in a moment, has proven to be very effective as one of the elements. What is it about? Let me just briefly explain what the ISO 15006 means. It is an international standard for increasing the energy performance of organizations. That's the target of this standard. How does it work? When you implement this standard in your organization, the first thing that you have to do is the determination of the energy consumption of all relevant processes. You set up a list of all of your relevant processes. I'm not talking about coffee machines or something. So I'm talking about the relevant processes. Then you set up such a list. You put them in an order, and then you check what are the so-called significant energy users. Those energy users, those processes that you would consider as very energy intensive. Okay, then you identify all influence factors. I just go quickly through it, and then I will show you what impact this standard might have. And then you identify all influence factors of the SEUs. So what are the drivers of energy consumption? Thereafter, you determine appropriate ENPIs, they are called, energy performance indicators, such as this one. This is an example. This could be an indicator of a heating process of a factory, of a university, whatever. A big heating system, for example. This could be the energy performance indicator. 1 point so megawatt hour per hour times runtime. So after determining the ENPIs, you assign ENPI owners, people that are responsible for the energy consumption of a particular process, of a particular system. So as soon as you have done this is being done on corporate level. So you check all of the relevant processes within the university, for example. You check what are the annual energy consumptions, what are the drivers. You put them together, drivers and consumption. Result is the ENPIs. Then you say who's responsible for this? This is the ENPI owner. You do it for all SEUs. And as soon as you have that, then you go on the process level. And you start to say, okay, what is the energy baseline at the beginning? Here's my ENPI. And this is the formula. And first of all, I say, okay, here's my process. This is one SAU. What is the annual energy consumption? So, okay, this is the baseline. For example, 300 megawatt hour per year. And then I start, and therefore it is so good for bridging energy efficiency gaps. As soon as you know this, as soon as you know what the energy consumption is, then you shall start an analysis of the energy efficiency potential. So the ENPI owner must be somebody who has knowledge about the process. Then he or she together with colleagues do an analysis of the energy efficiency potential. First of all, technological ideas are being developed. As soon as you have that, you check how much would they cost. How much would an implementation cost? Okay? And as soon as you know that, you set up a business case. This is necessary. So as soon as the business case is developed, then you go to those persons who have the responsible for investment decisions. You decide, and as soon as this is, you have the decision, then you can set targets. Then you can say, okay, I know what I can do in order to reduce the energy consumption, to improve the energy efficiency. I know who's responsible. I know what I can do. I have, set up a business case. I got the approval, and now I will implement it. And therefore, I can set targets. And that should be, reached after implementation. For example, in this particular case, 10%. Then you say, okay, this minus 10% is 2.7 megawatt hours. Responsible is this guy here, the owner. Yeah, he should be involved in setting targets. Of course, that's the idea. So then you will set the targets, and then you wait. Then you have the business period. Yeah, this is before a new business period starts, and this is after. So after the business period could be 1 year, but you could also check every month, for example. So after the business period, you check, you determine the current values, you compare. But before you compare, you usually normalize the target values because the circumstances, the conditions around the reality might have changed. The drivers, for example, the runtime might have changed. And therefore, you should normalize the target value from here to there. That's the idea, to be fair, to have a fair comparison. And then you compare normalized target values with current values. And the result is a variance. And the variance is allocated to this person. This guy is responsible for this variance. He knows this. He or she knows this. 8% is probably too much, and therefore this might result in a kind of discussion. Whatever. What could we do in order to reduce the variance in the future? In other words, you should determine some sort of action in order to reduce the variance in the future. And this would lead to an improvement of the energy efficiency. Okay, this is the idea of ISO 15006. Theory. So we were kind of impressed by this standard when it came up, 2014, and we had the opportunity to set up to establish an energy efficiency network 2015 that was based on an initiative of the German Ministry of Economics and Affairs. We had the chance to work together with 7 industry companies. We introduced over a period of 2 years the ISO 15006 and tried to find out what are the problems, how good does it work. The result was fantastic. These 7 companies could reduce the energy consumption tremendously, and the net present value, so the value of the improvements, were more than 70 million euros for 7 companies, so New Zealand dollars around about $30 million, only by working together, by going that way that I just explained. Yeah, this is energy consumption reduction by using ISO 15006. So, and the experience that we made during this 2 years of implementing ISO 15006 are as follows. During that time, we found that it was sometimes very difficult. That was not so difficult to find good ideas for improving the energy efficiency of processes, of machines, for example. The problems were that there were so many, not only barriers that we should remove, but there were also quite a lot of so-called, what we call prerequisites, that we had to fulfill in order to make it happen. To go from the start energy consuming process, for example, from this point to the energy efficiency improvement. So, and all what the challenges and the experience that we made, I put that into this roadmap here. So here are the different barriers that had to be removed on the one hand side, and here are the prerequisites. The interaction process with the person, what the starting point. You're kind of responsible for a process. Then you might develop ideas in order to reduce energy efficiency. You need right people to support you. You need energy knowledge, awareness, motivation, creativity, time, and so on and so forth. That worked more or less pretty good in most of the cases, but the biggest problem that we had were here at this point, almost at the end. That valuation, for example, valuation of the ideas, then submission, decision preparation, and so on and so forth. So to put it together, we could say that there are 3 core prerequisites that should be fulfilled in order to make a first energy efficiency idea on that side, to make it happen, to make something out of it. And the different core prerequisites are, first of all, exploring of energy cost-saving ideas. There are several barriers within this kind of thing, but that wasn't that big problem in most cases. The big problem was here, in all of the cases, the valuation of the ideas. That the people that worked in the companies that developed ideas in order to reduce energy consumption, they came quite early at the point that they said, okay, I have wonderful ideas and I want to make it happen, but the people that were responsible for making the investment decisions, they did not have any understanding. They said no, because of different reasons. So that was a big problem. And the third one was decision preparation, approval, and implementation procedure. That as soon as you have evaluated ideas, then you wanted to make them reality. You wanted to have a decision. You have to prepare the decision, all these kind of things. That was quite difficult. And what also was very relevant was, the framework around it. That we found that energy management and energy should work together with management accounting people, because we are talking about energy costs, about investment decisions. And together with project management. We found that it was sometimes problematic to give sustainability or environmental management departments the lead of such projects, because often such projects then were reduced to sustainability or environmental management projects, and that was not good for making them happen at the very end. It was good to say that there are positive, negative, positive side effects in terms of environmental management and in terms of sustainability, but the core value of energy efficiency measures is cost reduction. Okay. As I said, number one, exploring of energy cost-saving ideas was, in most cases, not the big issue, because there were internal procedures. There were people that had the knowledge in order to develop ideas for reducing the energy consumption, and there are standards that could be used. International standards, for example, those, for example, that I mentioned here. Big problems were, as I said already, business case development, evaluation of the idea. And this was this experience that we made during this project was very similar to another investigation that we carried out about 2 years before. I come to this at a later point in time. So first of all this. 2 years before this network project, we had studied a big number of different energy-related project valuations that came from different sources. Here are some examples, and the findings of this study that was published a year later was that in many cases, or the majority of the sample revealed that very often the results of such business cases, of such valuations of energy-related projects were not correct. Utilization of inappropriate calculation methods, very often. Calculation model not transparent, therefore difficult to understand, and so on and so forth. So we find a whole lot of weaknesses in many of the majority of the samples that we investigated. The biggest problem, the main finding was, however, that there is in the companies very often a communication problem between those that have an energy efficiency improvement idea and others that prepare and make the investment decision. Here's a typical situation. Here's Jim and Mike. They have an idea. This is an energy recovery facility, for example. They think this is a good thing. We could reduce the energy consumption tremendously, and they set up a proposal, for example, investment 6,000 euros, reduction of the energy consumption like this. And they give it because they are not competent to decide. They give this to the, for example, to the director of management accounting, Harold. And Harold looks at this and says no, because he does not understand, or the proposal is incomplete. It's not made for such decisions. So at the very end, in many cases, apparently good investment proposals were refused because of communication problems. And then we said what is necessary is correct, easy to understand, easy to use, transparent, retraceable, and conclusive valuation procedures are necessary. They are not there in most cases in the companies. So in other words, we need something that translates the technical ideas here into the language of decision makers. This is not there. We need such a thing. So after finding this out, we published publications about it. We did presentations, talked to many people. We found that others were the same opinion. And then it took like 2 more years when we heard that on the CEN level, CEN is the European Standardization Organization, that on that level, which is very strongly linked to the European Commission, so the European government, and they have started to discuss that that we should start to set up to develop a European standard on valuation. And then they asked us to develop a draft, for example. This is what we did, and just several weeks ago, I heard from that side that we developed a proposal, a draft. We sent to Brussels, and it was approved now. So it's going to be further developed in Brussels, so that we can expect that by the end of next year there will be a European standard on valuation of energy-related investments. So we call it VALUE. So I see that I don't have that much time. I jump a little bit. Sorry about this. Let's go to this just briefly. So what I want to say is, we had in mind ISO 15006, a good basis for trying to find out what the potentials are. The potentials are here at the Otago University, and to have some sort of mechanism to bridge the gap. On the one hand side. On the other hand side, we used standard draft, the draft standard of SEN, what has been developed so far, because we thought that it's a good basis for the valuation of possible energy efficiency improvement activities here. So that was the main initiative. We said, okay, let us implement 15,006 and let us use this evaluation draft. But after not very long time, we realized that it would take too long. Let us start with a kind of a quick investigation first, just to check where are the barriers here at the Otago University. And as soon as we have found them, we try to do something in order to remove them. And this is where we are now. And then the next step would then be, make these 3 projects happen, implement these solutions that have been developed, and then we could go that way, implement 15,001, 15,006. Okay, so that is the main initiative, that's a future. Test initiative was started 3 months ago or so, selection of appropriate entities. That was the first step. So what should we investigate? Are there any projects that were kind of easy to get data for? And then, particularly Mark was it who decided to enhance to go through that. To this 3 different projects. I mentioned this already. Extending district heating system, this and that. And then we determined the baseline values for this, projects. Then Mark developed ideas for improvement. Then he delivered all the data, the determination of effects. So the kilowatt hours per year that could be reduced, and so on and so forth. Then we did the valuation, and this is open, still open, the decision and implementation. So this is what we did. I showed this slide already. And so exploration of energy cost saving ideas and the valuation. We did this already, and the result is here. Let me just quickly go through it. I showed you this table. What is this? Number 1 is extending district heating systems. It is the energy supply of several campus buildings is comparatively costly due to the fact that their heating systems are electricity driven. The costs could be reduced dramatically by connecting the following buildings to district heating that are adjacent building already connected. Here, these buildings. So this would lead to roundabout, that would cost 1.2 million investment at the beginning. Energy efficiency costs money at the beginning, and then this would be the return. Okay, next thing was student flats. The regular renovation of the student flats could be carried out in a more sophisticated way in terms of increasing the energy efficiency of the buildings. Beyond the standard renovation, lounge pump heat pump, electric bedroom heating and hot water cylinder, the following measures would reduce the overall consumption, energy consumption. Shared boiler house, radiators, and centralized systems, plus incorporating on-site renewables. So this would cost 500,000 extra on top of the normal renovation, but that would be the result, the return on investment. So and then the third one was this year, the new research support facility and the physiotherapy building could minimize their energy consumption if existing adjacent buildings were considered in the planning process. So Mark, collected all the data that are relevant, we evaluated it, and the result was 380,000 extra, and return would be 1.1. So under this, adjustments of the relevant parameters, we got 11.5 million. So quite a bit. So the time is almost at the end. So I don't go into details. I wanted to show you, if you are interested in it, we could do it in the question round. I could go into the details how we evaluated the different projects. Last point is that was, as I said, was the more technical step. Okay? Trying to find out what is technically possible. Then evaluation. This is not a problem. here, not absolutely clear. We have to check this with the project management. And then we came to this area, decision preparation, approval, and implementation. What was the problem? We realized that energy management, together with Living Lab, for example, is not able to, make the decision. Yeah, the decision is made somewhere else. Therefore, we need to know the procedures that are relevant, that have to be fulfilled, that have to be used in order to kind of have, decision preparations kind of that are realistic, that would be approved. And therefore, we decided to contact the project management office. For example, with Andy. And this is where we are now. We have developed what we call streamlined submission to decision procedure. I don't want to go through it. So we have developed our own procedure that would be optimal for us. Yeah, that would be optimal not only for the 3 projects that we work on, but also for future projects. So what should be the steps, that have to be, go through from the very beginning of an idea until the decision. So this is our proposal, and now we are in the phase that we try to align them with existing forms and procedures of the project management office. So this is where we are now. So in other words, we're here in this phase. We have separated 3 different projects. We evaluated them. The results were great, and now we would like to make them or transfer them to reality. So we are here. We're having discussion with the project management. And this is, so if you like, our last step, coordinations and adjustments with Otago unit project management are necessary and intended, so that at the very end, we make this reality. That's the idea. Thank you very much for your attention. Thank you very much.